Today we're proving theorems, and this is day 2 of 3. In our first proof, it says given the measure of angle CAT is equal to the measure of angle BAG, and we're trying to prove that the measure of angle 1 is equal to the measure of angle 2. So the biggest complaint about students when doing proofs initially is that they just don't know where to start. So before you start writing in your proof frantically, let's just take a look at the diagram and look at the given information, what you start with, and then where you're going with your proof information, and decide what do I know already and what is my plan going forward. So if I look at my given information, I see that the measure of angle CAT is equal to the measure of angle BAG. And I realize that I'm trying to go to some smaller angles. So the measure of angle 1 is equal to the measure of angle 2. So two things are happening. I notice that there is an overlapping region right here with the measure of angle 3 is in both sets of the bigger angles. And also I notice that I'm going from big to small. Angle CAT and angle BAG are bigger than angle 1 and 2. So I'm going to have to subtract somewhere, and I'm going to have to use that reflexive piece. So I'm going to just kind of jot that down. The measure of angle 3 is equal to the measure of angle 3, and I know that's reflexive. So I know that. And I also know that I'm going from big angle to small angle. So I'm probably going to have to subtract. Again, this is, I don't know for sure, but this is just some ideas I'm coming up with. And the other thing I know, again, when I'm talking about angles and I'm putting them together, taking them apart, I can also look at angle addition postulate to see if that's something I need to work with. And now maybe I don't, but again, at least that gives me three things. So there's one thing, a second thing, and a third thing that maybe I'm going to have to look at in my proof. Okay, so let's actually look at this proof and figure out where we're starting. So our given statement is written in our proof, so the measure of angle CAT, so I'm going to mark it. Once it's in my proof, in the writing part, I'm going to mark my diagram. So the measure of angle CAT is equal to the measure of angle BAG. And again, I'm trying to get to the point where I can say 1 is congruent to 2. So now, the next thing I need to do, I know there's a lot going on there, so I need to first figure out what I can do next. So I know that there's nothing I can really do with that first statement within my proof, so I need to go to the diagram. So what I do know from the diagram is I have two small angles equal the big angle. So I can say the measure of angle CAT is equal to the measure of angle 1 plus the measure of angle 3. I can also say same thing for the measure of angle BAG. The measure of angle BAG is equal to the measure of angle 2 plus the measure of angle 3. And the reason I can say that is because the angle addition postulate. Angle addition postulate. Okay, so what do I want to do next with that? Well, again, there's not really too much I can use with the diagram, so now I have to go back to my proof. So when I notice that I have the measure of angle CAT is there twice, once there and once there. And the measure of CAT is the same as measure of angle 1 plus the measure of angle 3. They're the same. And I also know, if I look at the other part of that I have the measure of angle BAG, which again I have down here, is equal to the measure of angle 2 plus the measure of angle 3. So if I move things around or replace things like we've been saying, I can say that because the measure of angle CAT, which is the same as the measure of angle 1 plus the measure of angle 3, because I said in step 1 that measure of angle CAT plus the measure of angle BAG are equal, I can say that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. And the reason I can say that is because of substitution. Okay, substitution, property of equality, because I move things around. I had two equal statements, actually three equal statements, and I moved things around a little bit to come up with a new equality. All right, so what do I do from here? Again, let's go back and see if there's anything I can do from the diagram. And we talked a little bit with our plan that the measure of angle 3 is my overlapping angle. It's in both the measure of angle CAT. It's also in the measure of angle BAG. So I'm going to use that. So I have the measure of angle 3 is equal to the measure of angle 3. And that's reflexive. Reflexive property of equality. Now, how does that help me? That's always the question I have. What do I do next? Well, if I look at my statement in number 3, if I take out the measure of angle 3 is equal to the, and measure of angle 3 on either side of that, because I have the measure of angle 1 plus the measure of angle 3, and the other side I have the measure of angle 2 plus the measure of angle 3. And if I take both of those, what I'm left with is my step 5. I can say the measure of angle 1 is equal to the measure of angle 2. I subtract those out, which is actually, if you look back up to my original information, that's what I'm trying to get to. So what did I do there? Well, I subtracted. Subtraction property of equality. I subtracted out measure of angle 3 is equal to measure of angle 3. Okay, we're ready for our next proof. So our next proof says ZP is equal to LC and ZI is equal to OC. And that's our given information. So this time we're talking about segments. I'm trying to prove that IP is equal to LO. So again, let's talk about what do I know and what's my plan. What am I going to do? So let me just kind of mark up what I have. So I have that ZP, I'm going to mark that in blue, is equal to LC. That's the same. I also have that ZI is equal to OC. So I notice a few things. I notice that I'm kind of missing that part. I have, what I'm trying to find is this IP is equal to LO. That's what I'm looking at. I notice that I have some segment addition postulate I could use, right? 2 small segments equal a bigger segment. And perhaps a lot of times I'm using substitution. So I'm going to think maybe I need to use it again. I'm starting with some bigger segments and going to some smaller segments, so maybe I need to subtract. So let's just jot down some of these ideas. So I have segment addition postulate. Segment addition postulate's always an option. Something to think about. I also notice looking at this first statement, ZP is equal to LC, and I'm going to IP is equal to LO. So with that, I'm going from big to small. So again, maybe I have to subtract. I don't know for sure, but I'm certainly going to keep that in the back of my mind as I go with my proof. Now I'm ready to take a look at my proof. So I have ZP is equal to LC. I already have that written in my part of my proof, so I'm going to mark up my diagram as my given. This is the first time we're doing a proof where I'm not using both of the given pieces of information at the first step, and that's done on purpose. So we'll take a look at that later. So again, there's not really too much I can do just with that first step, so I'm going to have to look at my diagram. So what I can say from my diagram is I can use my segment addition postulate. So I can say that ZP is equal to ZI plus IP, right? 2 small segments equal the big segment. I can also say that LC is equal to LO plus OC. And I can say that because of segment addition postulate. Now, in doing this, I notice a few things. I've broken my pieces apart, my segments apart, and I have ZP here, and that's the same as ZI and IP. And I also have LC listed, which I have listed here. And again, I have something else equal to that because LC is the same as LO plus OC. So now what I want to do is I want to remove things around. So instead of writing ZP, which is in yellow, instead of writing ZP, I'm going to write ZI plus IP because in step 2 you told me they were the same thing. Now I'm also going to say, although ZP and LC are equal in step 1, I'm going to again replace that LC. So I have that's the same as LO plus OC. So what I did is I moved things around, I substituted. So substitution property of equality, and I did steps 1 and 2. Sometimes it's helpful to write the steps. It helps you kind of keep your mind going and going back trying to figure out what it is that you did. So I have that next. Now, this is where I'm going to rewrite my given. And I know this is hard for students initially, but you get better at them. And the more proofs you do, you'll know why to place things together and why to separate them. So in this piece, why did I put that there? Why didn't I just place the given initially? Well, this part of the given wouldn't have helped me initially, but it's going to help me now. So if I circle what I have ZI and I have OC. They're the same. So again, in trying to keep that balanced, what I'm left with is IP and LO. And if I look back to my basic information, I know that's actually what I'm trying to prove. So if I take ZI and OC out of the previous statement, I'm left with IP and equal to L, which is equal to LO. And like we just discussed, how do we do that? We subtracted. So that's subtraction property of equality, and I subtracted steps 3 and 4.